Okay, let's talk about this titration and neutralization practice. So as you can see, I've highlighted a few things here as I was reading, and that will help you answer the questions on the back page. Okay, so let's talk about this really quickly. So it says MAVA equals MBVB. You should recognize this as something very similar to the dilution equation, where Ma is the molarity of acid, Va is the volume of acid, Vb is the volume of base, and Mb is the molarity of the base. Okay, let's talk about these answers then. It says use the figure and reading above to answer the questions below. Define the following terms. So a titration is a neutralization reaction involving acids and bases to find the unknown Ma or Mb, so the molarity of acid or base. The equivalence point is where the concentration of H plus and the concentration of OH minus are equal and at the pH of 7. The endpoint is when the indicator changes color, signifying that neutralization has occurred. And titration curve is the shape of the graph of pH plotted against the volume of acid or base added. Okay, number 2 here. It says based on the figure, where does the pH begin and where does the pH end for this reaction? About 0 and 14. So let's look at the graph quickly. It says down here that the pH is on the y-axis and volume of alkali added would be the base. Okay, it starts here at 0, and as time progresses, there's more volume added and the pH rises. Okay, based on the figure, what is the independent variable? That would be volume of base added. And what is the dependent variable? That's pH. Remember, the dependent variable depends on the independent variable. So this directly affects this. Okay, and there's 3 questions here that involve neutralizations. So number 4 says, if it takes 54 milliliters of a 0.1 molar sodium hydroxide solution to neutralize 125 milliliters of an HCl or hydrochloric acid solution, what is the concentration of the HCl solution? Okay, so the unknown here is the molarity of the acid. So that's Ma. Setting it up this way, we have the volume of acid set equal to the molarity of the base and multiplying that by the volume of the base. Solving for Ma is pretty simple. It's just a matter of dividing by 125 milliliters to cancel on both sides 125 milliliters, and then you're left with Ma, which is 0.043 molar. Okay. The same process takes place here in number 5. If it takes 25 milliliters of a 0.05 molar HCl to neutralize 345 milliliters of an NaOH solution, what is the concentration of the NaOH solution? Again, the same thing occurs here. If you set it up, MAVA equals MBVB. To solve for VB, all you have to do is divide by 345 milliliters and do the same thing on the other side. 345 milliliters will cancel that unit, and you are left with MB, which is 0.0036 molar. That's the molarity of the base. And lastly, we have how many milliliters of 0.36 molar H2SO4 are required to neutralize 25 milliliters of 0.1 molar BaOH2, barium hydroxide. What we have is MAVA equals MBVB. to solve for VA, you just do the same thing. 0.36 molar divide by 0.36 molar. Those units cancel, and you're left with milliliters, which is VA. It's 6.94 milliliters. Okay. You'll notice these are actually easier than the typical dilutions because you can tell really easily which one is the acid and which one is the base. Okay, hopefully that was helpful, and let me know if you have any questions.